Okay, we're going to do the practice quiz for chapter 8. That is the hypothesis testing. Let's look at the first question. Okay. A random sample of 860 births in New York State included 426 boys. Use a 0.05 significant level to test the claim that 51.2% of newborn babies are boys. Do the results support the belief that 51.2% of the newborn babies are boys? Let's see, we have this N, the total sample size is 860. And out of this 860, 426 of them are boys. So what is your P hat? The sample proportion. That will be 426 divided by 860. Okay, I'm going to use my calculator. I'm going to show you how to use my calculator to get the answer. 426. Okay, 426 divided by 860. Okay, so that answer is 0.4953. I think I keep 4 decimal places, which means in percentage, I keep like 2 decimal places for the percentage. That'll be good enough. And then it's given alpha is 0.05. And I want to find the claim. Okay, the claim says 51.2 of newborn babies are boys. So they said, or the claim is this: P equals 0.512. Oh, I probably should just keep one more decimal, because 0.512, 0.5, yeah, okay. All right, so we want to claim this, and so we're going to write HO and HA, and HO will be just P equals 0.512, and the other one just it's not, because we want just claim. They didn't mention whether it's greater than or less than, so it's just not equal to 0.512. Okay, and once we finish this, the next step is to calculate the test statistic. The test statistic in this case is going to be this. It's Z equals P hat minus P over square root of PQ over N. And the good thing is we know all the information, so I have a 0.49535 minus 0.512 divided by the standard, the square root of 0.512, 1 minus 0.512, and the N is 860. So we need to find this answer. All right, and then if I do the numerator, I can get pretty much accurate of the numerator. So that would be, I can put things like that. Okay, so 0.493, sorry, 535 minus 0.512. So the numerator is a negative 0.01665, and the denominator, yeah, I do this first. I do 1 minus that first. So 1 minus 0.512, which is a 0.488, which is this parenthesis, and then I'm going to multiply by 0.512. See, that's the numerator, and then we're going to divide it by 860. So I get this tiny little number, and then I take the square root. Square root is this side. How should I do that? I'm sorry. Let me just do that again. Okay. So 1 minus 0.512 is 0.488. Instead of writing down the number, I just go ahead and multiply by 0.512. So that's this numerator, and then I divide it by 860. That's the denominator here. And then I take a square root of it. This time I'm very careful. I click that, square root of it. So the denominator is 0.017045. I think I just write it as much as possible, as accurate as possible. Okay. So I have a 0.01665 divided by 0.017045. So my answer is negative 0.9. Because for z-score we keep 2 decimal places, so that'll be 98. Okay. I got my test statistic. Okay. Then the next step, it doesn't really matter which method you want to use. You can use the critical value method or you can use the p-value method. Okay, so here's a z, and that's negative 0.98, and it's a two-tail test. So two-tail, that means for the left tail, and also this one just 0.98, and for the right tail. So the p-value is, if you look at the z table, if you have the z table to the left of negative 0.98, negative 0.9, negative 0.98, I get a 0.16354. So this is 0.16354. So very similar. This is also the same because they are very symmetric. So the p-value is 0.16354 times 2. Okay, so that would be 0.32708. You're going to compare the p-value with alpha, which is greater than alpha, because alpha is only 0.05. So you fail to reject H. Oh, okay. Now the other method is you get the critical value because you have a two-tailed test, and each tail will be half of alpha, and our alpha is 5%, so each tail is 0.025, and this is 0.025, and this is a 1.96, and here's a negative 1.96. Okay, so that's a critical value. And then here is the rejection region, but your answer is somewhere here. So that's your negative 0.98. It's not in the rejection region. So your answer here is also failed to reject HO. Now, I hope you can remember your HO or your claim is equal. So that's, you should do the flow chart, right? Okay. Does the original claim contain the condition of equality? Yes. Do you reject HO? No. So I fail to reject HO. So your answer is going to be there. Okay. So let me just write that here. You're going to copy things here. Okay. So you're going to say there is not sufficient evidence to warrant rejection of the claim, because you cannot reject the claim that, and the original question was 51.2%. Hold on. Here. 51.2% of newborn babies are boys. There you go. That's your answer. So you're going to show me the answer looks like this. So I make it really, really big so you can see Okay, so you should list the information was given in the question, and then you have to write whatever the claim is, and then give me HOHA, and calculate the test statistic. Make sure that you choose the right one, and then you either draw me this curve or this curve, and then give me the conclusion, and fail to reject HO, and then at the end you have to write your answer in words like this. So that will be your answer for the question number 1. All right, so we're going to work on the question number 2. Sorry. So we work on the question number 2. A Coke company claims the volume of a regular can of Coke is 12 ounces. So they claim that the content is 12 ounces, okay? A sample of 20 regular Coke gives the sample mean 11.79 ounces and a standard deviation 0.11. So that's from the sample. Sample size is 20 and the X bar is 11.79. Okay, that's ounces. And S is 0.11 ounces and alpha is 0.05 to test that cans of Coke have a mean volume less than 12. Okay, so it must be someone says, wait, I only have the X bar, it's 11.79. So the claim is mu is less than 12, okay? So I have my HO and HA or H1. That will be mu equals to 12. And this one will be mu is less than 12. Seems good? And I'm going to use a test statistic, which is a T, okay? And the question for T is we need a degree of freedom. Do you? Because it's a simple random sample, and we don't know sigma, and we just assume it's normality, whatever. So we're going to say, hey, I need to calculate a T, which is X bar minus mu over S over square root of N with a DF equals 19. All right, now let's do the calculation first. So that's 11.79 minus 12 divided by 0.11 over square root of 20. Okay, so the numerator 11.79 is negative 0.21 divided by 0.11, and the numerator of numerator, I can flip this up and make that to be here. If you don't know that, then that is totally fine, okay? So you can just do that according to this procedure. So I will get 0.21. I ignore the negative right now when I enter the calculator because I know the answer is going to be negative, okay? So this one times 20 square root, then divided by 0.11. My answer is negative 8.54. 8.54. Okay. I will draw the curve for T. I cannot find the exact p-value, but what I can do is I can find the critical value. Okay, the DF is 19. Is this a one-tail test or two-tail test? Here, less than, so it's a one-tailed test. So let me give you this. It's a one-tailed test. One tail, here's a t-table, right? So one tail and a 0.05, you see that? So we're going to use this column, okay? We're going to use this column. And the degree of freedom is 19, which is this guy. So it's 1.729. 1.729. So I have negative 1.729. And that is 0.05. That's one tail, okay? One tail and one tail test, and so it's one tail, 0.05, degree freedom, 19. So 1.729. And my test statistic is negative 8 point something. So it is in the rejection region, right? So it's somewhere here, 8.54. So you're going to reject. You're going to reject HO, okay? All right. And your claim says less than 12, and you are going to reject HO. So again, does the original claim contains the condition of equality? No, because it said it's less than 12, so it goes here. Do you reject? Yes, reject HO. So your answer is going to be like this. There is sufficient evidence to support the claim. Okay, so you are going to I'm gonna say there is sufficient evidence to support the claim, or support the claim that. Okay, now let's look at the question. What is the original claim says? The original claim says the original claim says cans of Coke, that cans of Coke have a mean volume less than 12 ounces. Okay, so if you are a customer and you get a simple random sample of 20 cans and you measured the average is 11.79 and standard deviation is 0.11, you think this is 11.79 is much lower than 12, so you claim that, hey Coke, you're cheating and your average volume is less than 12. You do this hypothesis testing and you reject HO. Look what your conclusion is. There is sufficient evidence to support the claim, which means most likely you're right. It is less than 12. Okay, so those are the two questions that I'm going to put in this. This is the review quiz for chapter 8, and in the actual quiz you're going to see two questions very similar to this too. So please make sure that you have the chapter review sheet and also have all the tables with you, and also make sure that you go over this video before you go to the actual quiz. Okay?